So hey guys, welcome to our YouTube channel. So in this tutorial, we are going to solve a LeetCode problem named toSum. Given an array of integer nums and an integer target, return indices of the two numbers such that they add up to target. So here what we see is we will be given an array. Let's suppose 2, 7, 11 and 15 are the given arrays, and we have to return a target value 9 such that any two numbers add up to 9. Let's suppose here 2 plus 7 will give us 9. So what we have to do is we have to return the indices of 2 and we have to return the indices of 7. So we will return 0 and 1 as output. So let's try to analyze it and then we will code it. So let us try to solve it using a brute force solution. So let's suppose there's an array and the values are 2, 7, 11 and 15. So what we are trying to do here is we will take an I value, and I value will start from index 0 and it will go throughout the array till n, where n is equals to size of the array, and we will take another value, that is j, and j will be equals to I plus 1, because we do not have to take the same element twice. So what we will do is take j from I plus 1 and we will iterate throughout the array. So it will also iterate, let's say n minus I times. Every time it will iterate n minus I time. So what will happen if we are taking one for loop? If we are taking one for loop, and let's suppose it goes from I equals to 0 to n one time, and then another for loop, and if it goes from, let's suppose, I plus 1 to n times, then we will check if, so if these two, like I, num of let's say I, and num of j, whether the sum of these two is equal to target or not. If their sum is equals to target, we will simply return an array having I and j value, that is the index value of nums of I and index value of nums of j. And if not, we will simply return a empty array or an empty vector. So now let's check its time complexity. So here in the first case, let's suppose it is traveling n times, and in the second case it is traveling n minus I times. So first it will travel n times, and for every n times it is going to travel n minus I times. So let us say the order will be equal to n into n minus I times, and let's suppose if we are neglecting this I, so it will come with order of n square. Here the problem is going to be solved, but in order of n square. So obviously this is not an optimized solution, so we have to optimize it. So now let us try to optimize it. So now let's try to code it in an optimized way. So here what I'm going to do is I'm going to take a map, and a map always comes with a key and a value pair, and we are going to check whether this key and this value is in our map or not. If it is in our map, then we are simply going to return it, and if it is not in our map, then we are going to insert it. So for example, let's say we are taking an unordered map, and let's say the key value pair is int and int, and let's call it mp. Okay, so now we will take a for loop and we will iterate from I equals to 0 to n, and what we are going to do here is we are going to take a value, let's suppose int x, and that is equal to target minus x, target minus nums of I, whatever nums of I we are having. And now we have to check whether this nums of I is present in our map or not. So what we are going to do is we are going to check if mp dot find our x value is present in our map or not, mp.end. So if if mp.find value is not equal to mp.end, so definitely it will be present in our map. So what we are going to do is simply return an array having mp of x value and the current position of I. And if it is not present here, then what we are going to do is we are going to update our map with nums of I. Nums of I is equals to I. And if we travel this entire for loop and if we do not get any value, then we will simply going to return an empty array. Here, let's suppose I is at 0th position. So when I is at 0th position, we are taking x value. So let's suppose the x value will be 9 minus 1, that is 8. So we have to check whether 8 is present in the map or not. So we can see that 8 is not present in our map. So what we are going to do is we are going to put it in the map. So here it will be 1. The key value is 1 and the value is I, that is I is 0, its position value. So it is currently it is on the 0th position, so that's why we are putting a 0. And now let's say we moved on to second value and our second value is 2, so the x value will be 7. So we have to check whether 7 is present in our map or not. So there's only one value and that is not equals to 7. So what we are going to do is we are going to put that value and its position in our map. Now again we will move forward toward our third element, and our third element is 4. So our x will be 9 minus 4, that is 5. So again 5 is not present in our map, so what we are going to do is I am going to put my 4 and its position in our map. And now we are going to search our fourth element, that is 5. So when I am going to take 5, so 9 minus 5 will be equals to 4, and here we see that our 4 value is present in the map. Fourth value is present in our map. So what we are going to do is we are going to simply return from here, and what we are going to return of the keyword 4, that is 2, and the current position, that is 3. So I'm going to return 2 comma 3. So that's how I'm going to solve it, and it is going to give me a correct answer. And if for example we traversed the entire array and we do not get any answer, then we simply have to return this value. So now let's talk about the time complexity. So here I am using only one for loop, and that is running n times. And here in mp.find I'm just neglecting it because it will run for a negligible amount of time. So I'm neglecting it. So that's why our for loop is running n times, and that's why our order will be order of n. So in the previous solution, in the brute force, it was taking order of n square, and now it is taking order of n. So order of n is better than order of n square, and that's why this is an optimized solution using you can say a hash map, or you can say unordered map, or simply a map in C++. So now since we solved our problem, we discussed its solution. So now let us try to code it. So what I'm going to do is I'm going to take an unordered map in the beginning, and let's say key value pair will be of type int, and let's call it mp. And now I will take a for loop and int I is equals to 0, I less than nums dot size, and what I'm going to do is I plus plus, and here I'm going to take a value x that will be equal to target minus nums of I. So it will give us the value, and then I have to check whether this value is present in our map or not. So let's say we have map dot find our value x, and if it is not equals to map dot end, so definitely it will be present in the map. So what I'm going to do here is I'm going to return is the value of map of x and the current value of I. And if it is not present here, so what I'm going to do is map of nums of I will be equals to I. So I'm simply going to update our map. And if we do not get any pair and we have traversed our entire array, so what I'm going to do is return a null vector. So let us try to run it. So it is saying that it is faster at 96.08% of C++ online submission for 2sum. So it is very fast and it have crossed 96, almost 96% of the solution. So if you like our video, please don't forget to like, share and subscribe. So that's all for today, and we'll see you again.